In this video, we will discuss the main concepts from topic 12 and 13. This topic can be divided into three sections. The first section is about magnets, the second section is about electromagnets, and the final section is about electromagnetic induction. From the first section, which is magnets, you must know the following. Number one, all magnets have poles. Like poles repel, while unlike poles attract. Number two, the shape and direction of magnetic field. Number three, you should be able to interpret magnetic field. Now, when it comes to interpret magnetic field, so they'll give you magnetic field around a bar magnet or a magnet, and they will ask you for two type of things. Number one will be the strength of magnetic field, and the second one will be the direction. Number four, use of plotting compass. To find the shape and direction of the field. I can add a little bit information here when it comes to shape and direction of the magnetic field. I can't talk about the shape here, but I can tell you about the direction, which is always from north to south. Before I move on to the next section, I would like to remind you of something that we have done in our last topic. Just like static electricity, in case of magnets, we can also produce uniform magnetic field. To produce uniform magnetic field, we'll need to have north here, and I can have south pole. So if I have north pole and south pole, they're both facing each other. In this case, I can have a uniform magnetic field. You need to remember these will be parallel lines, and they will be at equal distance from each other. Let's say this is 1, 2, 4, and the distance between them is going to be d. If you look at the direction, I followed the same rule. The direction is always from north to south. I can tell you one more thing here, and that is direction is determined by placing a north pole in magnetic field. Like when we were doing the last topic, we said we will use positive charge. That was our something called test charge to determine the location, to determine the direction of electric field. If I have to determine the direction of magnetic field, then I'll always use north pole, and I'll place it in the magnetic field, and that will tell me the direction of the magnetic field. So in other words, I can say the plotting compass is basically my north pole. So when I place it in the magnetic field around a magnet, it shows me the direction experienced by the north pole. The last thing on this section is about magnetic induction. It is same as electrostatic induction that we have done in last topic, static electricity. When it comes to magnetic induction, what happens in this case is if I have a permanent magnet, when this permanent magnet will come close to magnetic material, this magnetic material will become temporary magnet. This is what we call magnetic induction. So for instance, let's say if this is my north pole and this side is my south pole, then this will become south pole and this side will become north, and we know the opposite poles will attract. But remember, as I said here, it will become temporary magnet. If I make this magnet disappear, then it will no more have these poles. These poles only exist when this magnetic material is placed next to a magnet or it is touching a magnet. This is all that we need to know from the first section called magnets. We will now look at the next section called electromagnets. So when it comes to electromagnets, we can say any current carrying conductor will be an electromagnet. So we can start with straight wire. Number two, we can then say, instead of having a straight wire, we can have coil. The third one, we can have coil plus an bar inside it. This coil is called solenoid as well. Now this is a condition. If you have a straight wire and if it has no current in it, it will not be an electromagnet. If you have a coil without current in it, it will not be an electromagnet. If you have coil plus iron bar inside it, but if there is no current, and that means it will not behave as an electromagnet. So for them three to behave as electromagnets, we will say if current passes / flows, then it will become electromagnet. Now out of these, this one will be the strongest electromagnet. This one will be the weakest electromagnet. So I want to increase the strength of the magnet, then I'll have to change it from straight wire into a coil. If I want to change its strength even by a bigger factor, then I'll have to use iron bar inside it. But I did mention something more here. That is about the current. So I can say the strength will depend on number one, current in the coil, and number two, I can say number of turns. This is for the coil. Okay, possible investigation question. Now to determine the strength of the magnet, or to find out if it is becoming stronger magnet or not, what we can do is we can pick paper clips with it. If it picks up more paper clips, that means the strength has gone up. If it picks up less paper clips, then I'll say the strength has gone down. Once we have done this part, we need to do two more things here as well. We will need to know about, so we've seen electromagnet. I'll have straight wire, and then I have here the solenoid. You must know how to determine the magnetic field, the shape and its direction around these two types of electromagnets. So when it comes to the straight wire, we can say we use right hand grip rule to determine the direction of field. And you have to remember one more thing. In this case, the field will be circular. The circular field around Y. When it comes to the solenoid, the field outside is same as the bar magnet. Inside solenoid, you will have uniform magnetic field. We can make use of plotting compass on both of these if you have to do an experiment. To determine the north and south poles of a solenoid, what you will need to do is you'll have to look at the coil from a side. And when you look at the coil from a side, you'll observe two things. You'll see either the current will be going clockwise or the current will be going anti-clockwise. If it is clockwise, then this will be your south pole. So what we do is, to memorize it, we draw it like this. This tells us that the current is clockwise on this section. When you see the solenoid from a side and you observe that the current is moving anti-clockwise, and that will be your north pole. And to remember this, what we do is we write down N like that and we put arrows. This is telling us that it is anti-clockwise. The last section on electromagnets is about the motor effect. Now, when it comes to motor effect, what we do is we place conductor in a permanent magnetic field. And you know now, when this conductor will carry current, it will become a magnet. You can say when current is supplied, it becomes electromagnet. So once it becomes electromagnet and there's a permanent magnet, when two magnets are together, what will they do? They will start applying force on each other. So in this case, the outcome is force. To determine the direction of this force, direction, we use Fleming's left-hand rule. So when it comes to Fleming's left-hand rule, we have thumb, we've got first finger, and we've got second finger. Thumb is for the force, first finger is for magnetic field, and the second finger is for the current. You have to remember they must be at 90 to each other. This is what we call motor effect. So in motor effect, your input is DC, direct current, and your output is force. And to determine the direction of this force, we use Fleming's left-hand rule. In this case, we use thumb, first finger, and second finger. Thumb points in the direction of the force, first finger points in the direction of the magnetic field, and the second finger will point in the direction of current. They all must be at 90 degrees to each other. So this was all about qualitative analysis of motor effect, but this force can be quantified. To determine the magnitude of this force, we use equation F equals B times I times F, where B stands for magnetic field, I stands for current, L stands for the length of conductor, and F is the force that will be experienced by the conductor. Now it may involve unit conversion. That's one thing very important for you to remember. In addition to that, you need to remember this is in Tesla. That's the unit for magnetic field. This is to find magnitude of force. We use that equation. This is all that you need to know on electromagnets. Now let us consider electromagnetic induction. So when it comes to electromagnetic induction, you have to remember the core concept here is field lines must get cut by conductor. Number one. Number two, you need to remember your input will be force and your output will be AC, alternating current. That's what you have to remember, alternating, and that's very, very important. Now for this to happen, field lines must get cut by a conductor. We can have different arrangements. We can say number one, I can have fixed magnet and rotating conductor. Fixed magnet plus rotating conductor. If this is the case, field lines will get cut and the outcome will be AC current. Second option could be the other way around. I can have fixed conductor plus rotating magnet. Okay. Third one, third arrangement could be oscillating conductor plus fixed magnet. Fourth option could be oscillating magnet plus fixed conductor. Number 5, I could have AC electromagnet. Electromagnet that is working on AC current. If that's the case, the magnetic field will continuously change. And then if you place next to it a conductor, then also the outcome will be AC current. Now remember one thing here. This is something that we say happens in transformer. The first one here, this is for the generator. So this is all that you have to remember from the section called electromagnetic induction. And if you keep this in mind while watching the next video, which is about the exam questions on magnets, electromagnets, and electromagnetic induction, things will make much more sense to you and the information will become more accessible. This is all that you need to know on this topic. This is all for this topic. I wish you all very good luck with your exam preparation. Thank you.